Hi everyone. So today we'll be solving two questions. The first question that I've taken is this one. ABC is a quadrant of a circle of radius 14 centimeter and a semicircle is drawn with BC as diameter. Find the area of the shaded region. So you see, this is the quadrant A, B, C. This is the quadrant part and and this is the semicircle. This is semicircle with BC as the diameter. So what you have to find the area of the region between that is between this, or you can say between these two arcs. This is the shaded region. You have to find this area of the shaded region. So first let us observe how we can find this. So if you notice that this area, shaded area, is nothing but this total area minus this quadrant area that we have observed. So we'll be writing in this way. And one more thing, radius of the this quadrant is 14. So AC is your 14 centimeter. 14 centimeter. So I can write this 14 centimeter as the radius of the quadrant. So let me write radius of the quadrant part is 14 centimeter. Okay. And then there is this is the diameter. So I have to find out the radius of the semicircular part also. So let me find out. So for finding the radius of the semicircular part, I have to first find out the length of the diameter BC, and this diameter is nothing but the hypotenuse of this right triangle. So very easily we can find it out. So let us do this work first. So by Pythagoras theorem, let me write it here. By Pythagoras theorem, in right triangle ABC, this BC, your BC will be equal to under root AB square plus AC square. So we can very easily find out. So this is your under root. Both are 14. AB is also 14. AC is also 14. Or this is equal to under root 2 into 14 square. Therefore, BC comes out to be 14 will come out 14 and root 2 centimeter. So this length of the diameter or of this semicircle is 14 root 2. So therefore, radius of the semicircular part, that is if this is the center, say O. So this is your radius of the semicircular part and this is actually your radius of the quadrant part. So this will be your BC by 2. So it is 14 root 2 by 2, that is 7 root 2 centimeter. So this is the radius of the semicircular part. I have written RS, S suffix for semicircular and Q for quadrant. So for not avoiding confusion, I have written these suffixes. So this will be recursive. First of all, I am finding the values of this RS. Now next one I do. Now I have to find the area of the shaded region. So let me find out the area of the shaded region is the whole area minus this quadrant area quadrant area. This we have observed. Now again you see what is the whole area. This whole area can be written in this way. So this is your triangular part. Okay, the triangular part plus this semicircular part. Triangle area plus semicircle area will be the whole area. So let me write down now. So this is whole area is your, what to write, let me write here. Whole area is your area of triangle ABC plus area of semicircle with BC as diameter, right? BC diameter you write. Diameter minus quadrant area, that is area of quadrant ABC. This is the quadrant, this is the quadrant. So this is clear. So after that I'll write the formula. Actually you see, we will be finding out in one step. So this is a right triangle, so half base into altitude. Using the formula half base into altitude, half of AC into AB. AC into AB plus semicircle area is pi r square by 2. So pi rs is the radius of the semicircle, pi rs square by 2 minus quadrant area will be 1/4, 90 by 360, or let me write quadrant 90 degree by 360, theta by 360 into pi rq whole square, radius of the quadrant rq. That's all. Now put the values. Half of AC is your 14, AB is also 14, plus value of pi I will be taking 22 by 7, 2 is there, and what is RS? RS is 7√2 whole square. So 7√2 whole square minus is 1/4, 1/4 pi, again I write 22 by 7, and what is RQ? RQ is 14, so 14 into 14 I write. Okay. Now you see, now do the calculation. 7, so 14 7 is 98, plus now do the calculation. You see, so 7√2 is your, that is 7 square into 2 I can write. 7√2 whole square is 7 square into 2, that I can be written in this way. In the next step also you can do 7 square into 2, so these 2 getting cancelled, 1 7 getting cancelled, so we are left with 22 into 7. Then minus here also, 7 2 ja 14, and then here let me cancel 2, and then here it is 7. So what is left with 22 into 7, 22 into 7. Now you observe, there are no need of multiplying because they are similar terms, so they stay or they are getting cancelled, so you are left with only 98. So the answer is 98 unit is centimeter square. So this is the answer. So the calculation is so easy, as you see, since I have done in together, so I don't have to calculate, they are getting cancelled. So in this way we manage the calculations, and also we have used suffixes for avoiding confusion of the radius values for semicircle and quadrant. Okay, I think it's clear. Okay. Next question. Calculate the area of the region common between the two quadrants of the circles of radius 8 cm each. So that means, you see, these are 90 degrees, so obviously this is a quadrant. You see, this is a quadrant with this as the center, and this is another quadrant with this point as the center. So what is the common region? The common region is, this region is the common between the quadrants. So that means you have to find the area of this region. So how to find this out? So for that, what will I do? First of all, I will join this diagonal. Actually this forms a square, you see, as all the sides are equal and this is 90 90, so obviously this is a square. So I will be joining this diagonal of the square. Just a minute. So this diagonal, actually I should be drawing it, okay, like this. Okay, so this diagonal divides the um, region, this common region into two equal halves. Okay. So this area is equal to this area. And if you observe, and so that's why this area will be twice of these areas. So now again you observe this area, let me fill this up. This area you see, what is this area? This area is nothing but a segment area, as you see. Let me give a name, actually it will be easy. A, B, C, D forms a square. So this area is your quadrant ADC area minus this triangle ADC, that is, this is a segment. Similarly, this is also segment when for this quadrant. So that means if I can find out the segment area, so twice of that segment area will be the required area. So we'll be doing in that way. So let me write, or let me give names, say this 1 and 2. That will be easy. So let me write the required area is equal to area 1 plus area 2, or we can write in this way, twice of area 1, since area 1 is equal to area 2. They are identical because they are segments of identical quadrants. That's why these areas will be same. So I can find this. So how to find twice of area 1? So this twice of area 1 is nothing but segment area. Segment area. And let me give a name. I am taking area 1. So give a name here. Say give point. Say A, B, C, D, E. Say E. So segment AEC. Give a name, then to be clear. Segment AEC area. So segment area, as you know, it is quadrant sector area minus triangle area. Sector area, or we can write, quadrant area. Quadrant AEC area minus area of triangle AECD. AECD is the quadrant. Is it clearly visible? Let me write it again. It is AECD. Okay. This quadrant area minus area of the triangle ADC. So this is the segment. So now let me write down the formula. Quadrant is 1/4 90 by 360 into pi r square. And what is r for? This is your r, 8. So I can write 8 into 8. 1/4 pi r square minus area of the right triangle half base into altitude. Then this base is 8, altitude is also 8. So again it is 8 into 8. Fine. So now let me cancel out 2. Here it is also. It is 4. So now what can I take out common? You see, 8 to the 16 can be taken out. 16. If I take out 16, then pi is left. Pi minus 2. Okay. So see, I'm doing the calculation. 2 into 16. And what value of pi I'll be taking? 3.14. 3.14 minus 2. So it is 2 into 16 into 3.14. This is 1.14. 1.14. So this calculation is easy. We can first multiply 2 with this. So 200, 228. 2.28. This into this, 2.28 into 16. And if you know the table of 16, we can very finally write the answer. So it should come out as 36.48. Or if I take 3.14, then 36.48. 36.48. 0.48 centimeter square. So this is the answer. Actually 16 to the 30, yes, into 36.48. So in this way we solve this question. Okay, so this technique I have shown you how I do. We solve in one step, and then I take common and choose proper value of pi, and I do groupings so that I can use my tables and I don't need of doing any rough work. In this way we can save our time and our labor also. Okay, so that's all for today. Bye.